Let's recap trig. So the trig ratios, all to do of course with the right angled triangles where we begin, and I guess we had to name the sides. Hypotenuse, the largest side. We refer to a particular angle, the one next to it we call adjacent, the one across opposite. That then gives us our three basic ratios we started with, sine, cosine and tangent, and then we discovered the reciprocal ratios, which I personally think are very meanly named, because why did they make cosec the reciprocal of sine and sec the reciprocal of cosine? Surely the co with the co would have made more sense. No, let's just confuse everyone. So sine x equals the cosine of 25. The co in the word simply means complementary. And complementary angles, you'll recall, add up to 90 degrees. Sorry, the sine of x is cosine of 25. That means x must be 90 minus 25, so 65 degrees. But it means we get a question like this, where we've got the cotan and tan. Again, those two angles must be complementary. So they must add together to give 90. And so we're able to find x. X is 40. There are basically three right-angled triangle trig questions. Finding a side that is not the hypotenuse. First thing to do is to identify which ratio. In this case it's the tan ratio. And we complete it by multiplying by 13. There's our exact answer. We'll go to our calculator to one decimal place. The second type is where it is the hypotenuse we're trying to find. Now when we set up our ratio, that means the pronumeral ends up on the bottom of the fraction. I mean, we could use the reciprocal ratios and get it on the top of the fraction, but unfortunately our calculators don't have a cosec button or a sec button or a cotan button, so we've got to put it in terms of those three basic ones. But that's okay. 5 over x is sine of 32. It simply means instead of multiplying by the trig to find the value, we divide by the trig. So it's 5 over sine 32, 9.4. The third type is when we have to find the angle. So cosine theta is 10 on 13. Theta is the inverse cos, so that inverse function of the cosine, 10 on 14. That'll give us an angle. And the only thing we've got to be careful with our calculators is to make sure it's set on the right angular measure. And at this stage that's degrees we're using, so make sure it's in degrees. So 44 degrees, 25 minutes. There are some exact ratios. They crop up a lot and we know their value and we should be able to recall them. How do we get them? The first one comes from this triangle. It's an equilateral triangle. All the sides are 2. All the angles therefore are 60. And I divide it in half and it creates a 30-60 triangle. And that allows me now to find the ratios. Got to find the third side, bit of Pythagoras, that's the square root of 3. So I can now read off my triangle. Sine 30 is a half, cos 30 root 3 on 2, tan 31 on root 3, and then 60s. Sine 60 root 3 on 2, cos 60 a half, tan 60 root 3. Notice the complementary ratios are the same. So cosine 30, complement of 30 is 60, cos 30, sine 60 the same, and so on. The other exact triangle comes from an isosceles triangle, which means they're both 45 degrees. 1, 1, hypotenuse, square root of 2. Reading off that, sine 45 is 1 on root 2, so is cosine 45. Tan 45 is 1. Now, however you choose to memorize these is up to you. I personally always just remember the triangle and read off that. Some people just remember the decimal approximation because it comes up on the calculator so often. For instance, root 3 on 2 is 0.8660. Some people do it this way. It's really interesting. If you draw this table of values and put in all of those numbers, but include 0 and 90, something interesting happens. The sine ratio is that. Root 0 on 2, root 1 on 2, root 2 on 2, root 3 on 2, and root 4 on 2. 0 on 2 is obviously 0, sine of 0 is 0. Root 1 is 1, you get a half. Root 2 on 2 is the same as 1 on root 2. Root 3 on 2 and root 4 on 2 is 2 on 2, which is 1. The cosine, you write it backwards. And then tan, remembering that tan actually is sine divided by cosine, you then just get the numerators divided by each other. So root 0 on 4, root 1 on root 3, and so on. It's an interesting way of remembering those ratios. How do we measure angles then? So we get a lot of practical problems where we have to physically measure angles and find out what they are. So angles of elevation, that happens a lot. So the name tells you what it is. Angle of elevations. How far do we elevate or lift? So it's measured from the horizontal. The way of writing this is it's the angle of elevation of B from A. So the angle is where it's from, where you're looking from, if you like. Then there is angle of depression. Depression is to lower. So we lower from the horizontal. That would be the angle of depression of X from Y. Angle of elevation will always equal the angle of depression, because if you were to slide those two diagrams together, you would end up with alternate angles with parallel lines. So they will always be the same. Then there's these things, compass bearings. So we have our north, east, west and south, which is where of course the word news comes from. You did realise that, didn't you? There you go. That's where the word news comes from, because it's information from all around the compass. News. Now, it's my story, I'm sticking to it. Okay, so you got north, east, south and west. We can divide them in half, and then we have north, east and so on. And then you could divide by half again. But when you're naming it, you start with the more, what's the word I'm looking for? More important. So north, I suppose, is more important than northeast, if you get what I'm meaning, sort of like when you subdivide it down. So that would be north, northeast. This one would be east, northeast. So we start with the east and so on. And I suppose theoretically we could divide that in half again, and halfway between north, northeast and northeast, well, northeast would be the more important one, so that would be northeast, north, northeast. Yeah, it kind of starts getting a bit ridiculous. Before I go to that one, what we then tend to do is say, well, rather than do that, I'm going to start at north, and how many degrees am I going to the east or the west? Okay, but you always start at north, this is for a true bearing, and measure clockwise. So there's X and Y. I'll place a compass at where I'm measuring from. So in this case, it's from X. There's the compass. That angle's 30 degrees. So this would be a bearing of 120. Now, often you see a T after it to say it's a true bearing. So 120 true bearing. If I did it the other way, I'd say, well, south, and I'm moving 60 degrees to the east. The thing about true bearings, always 3 digits. Always write it as 3 digits. So if I did the bearing of X from Y, that would be 300 degrees. Start at north and go clockwise. Using it the other way, north 60 degrees west. Okay, so that's a very quick recap of our basic trig. 2 to 5, you'll notice I've just said, pick some. I think it's just one to make sure, do you know how to use your calculator? So just pick some, do them. But then there's other questions too.